Today we're going to be looking at some geometry with our familiar concept, the Cartesian plane or the coordinate plane. So remember that coordinate plane is a plane divided into two regions with a horizontal and vertical line, which we call the x-axis and the y-axis. The x being the horizontal, the y being the vertical. The location of the coordinate of a point is given by that ordered pair x comma y. Remember, always x, then y. Okay? We're going to be looking at two things today. We're going to be looking at segments. We're going to be finding the midpoint, and we're going to be finding the distance. And along the way, we're going to review the Pythagorean Theorem that a lot of you probably remember. So first, let's remember, what is a midpoint? So you want to ask yourself what we talked about last week. What is a midpoint? Okay, so hopefully you're remembering that the midpoint, or the middle of a segment, is a point that bisects a segment. Remember, bisect means to cut in half. So it cuts a segment into two congruent halves. So when we look at points on a plane, for example, like number 1, you can plot the point 3, -4, and 3, 8, and see if you can find that midpoint. So why don't we go ahead and do that? So for 3, -4, remember it's again x comma y, so I'm going to go to 3 on the x, go down 4 on the y to get my first point, and that would be point A, right? Let me go ahead and label my point here. Point A. Always want to label which point is which, right? And then we've got our second point, B, which is at 3, comma, positive 8. So I'm going to go to 3 on the x, and then go 8 up on the y to get my second point. Once again, please label them so we know which one's which. So there's B. And then I can connect these 2 points. Oops, that looks more like a beta. This is a B. There you go. So now we just need to connect these 2 points, and we'll be able to create our line segment. So if you look at this, we're going straight down from B to A. So hopefully that's showing you this is a vertical line. So to find the midpoint, you're really asking yourself, how do I cut that segment in half? So you can do a really simple thing with these vertical lines. You can just go count till you hit the middle. So I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a total of 12 spaces. So that means halfway up is 6. So I can go ahead and say, well, where is 6 spaces? Well, I'm just going to go ahead and check 6 spaces. 1, 2, 3, 4, 5, 6. My midpoint should be right here, right? So that's my midpoint, which I can call M or whatever you'd like. And let's write that coordinate. That's going to be 3, 2. Okay, you can do the same thing for number 2. So go ahead and plot your points. 5, -2 for C, -3, -2 for D, and see if you can figure out that midpoint just by looking at your diagram. Okay, so again, plot your points and label your points. Hopefully we see C and D right here, 5, -2, -3, -2. And what do you think? What do you think that midpoint is going to be? Well, remember again, if I'm counting, because this is horizontal, so it's super easy for me to go just straight across. So I can see it's 1, 2, 3, 4, 5, 6, 7, 8 spaces, right? Away, and half of 8 is 4. So I would just count backwards and go 1, 2, 3, 4. Then I know my midpoint of CD should be right here. So that's going to be my midpoint. Again, I'm going to call it M for midpoint, but you can call it whatever you like. This is M, and I'm writing my coordinates for M, 1, -2. All right? So it's super simple to see it right off your grid, right off your Cartesian plane, looking at horizontal and vertical lines. However, what if we end up with one of these? So let's go ahead and plot EF and see that segment. So 4, 7, -2, 9, can already see with these 2 points for E and F, it's not horizontal and it's not vertical. It's slanted. So when it's slanted, you may get lucky and it may be easy to kind of see where that halfway point is, but sometimes you're just not exactly sure, right? So I might estimate, okay, it looks somewhere around here, but am I 100% sure? I don't know, right? So I think it's somewhere around here, but I'm not really sure. And that's where having a formula can be really, really useful.
Okay, and we'll talk about that midpoint formula in class. Let's go ahead and skip down to the next big idea of this section, which is distance.
And you can find distance in 2 ways. The first way using the Pythagorean theorem, which some of you may remember, it's when we have any right triangle, right? It must be a right triangle, which means you have to have one of these 90-degree angles, all right? So for any right triangle with hypotenuse C, and remember hypotenuse means the longest leg, the longest side. Oops, not super messy. Let me clean that up a bit. So that's your longest side. And that's always going to be directly across from that right angle. So if you imagine that little corner as an arrow, it's pointing straight at that C, that's always the hypotenuse, okay? So with the hypotenuse C and 2 other legs, A and B, A squared plus B squared will always equal C squared. So really, the only thing that really matters is you need to know what C is, because A and B are interchangeable because addition is, the order doesn't matter, it's commutative, okay? So we're going to talk a little bit more about how to use the Pythagorean theorem for just.
All right, so how can we use the Pythagorean theorem to find distance? Well, we go back to the idea of that right triangle. So I'm just going to go ahead and do a quick sketch of these 2 points D and E on my coordinate plane. So D is at 3, 4, and then E is at -2, -5. Oops, there you go. And if I connect these two, what I do is I create a hypotenuse. So what I want to do now is I want to be able to drop this down and create a right triangle. And you can create a right triangle from any 2 points. All you need to do is basically think slope, right? We're going to think rise and run, right? So since D was at 3, 4, just put this down here, and E is at -2, -5, if you had a grid, you can literally just count up and count or down and count left or right. Or you can just take the difference, right? So here, the vertical distance from D to E is 4 and then -5, so that's going to be a 9. And then this horizontal distance goes from -2 to 3, so that's a total of 5 units. And again, you could count, or again, like I did, I subtracted. 4 minus -5 is 9. 3 minus -2 is 5. So then what we have is we have this lovely right triangle from D to E, right? This is 9, this is 5, this is the right angle. And then the distance I'm looking for is my hypotenuse, C. So then all I have to do is plug it in to the Pythagorean theorem. And remember, again, the most important part is knowing what side is C, because A and B are interchangeable, right? So since we're looking for C, all we have to do is plug in 9 and 5 for A and B. And again, it doesn't matter which one's A or B because that sum is going to be the same regardless, okay? So 81 plus 25 is equal to C squared, which gives me 106. And then since I'm looking for C, remember from Algebra 1, your inverse operations, square root that, and we're going to get C equals the square root of 106. Now you might think, cool, done, I've got my answer, but look back at the directions. Simplest radical form. And this was on your diagnostic, and this is going to be important. You're going to want to remember simplest radical form. If you don't remember how to do that, remember you can create a factor tree and pull out pairs. And let me just show you that work really fast. Okay, so what I want to do is I want to take that 106 and break it down into its prime factors. So I can take out a 2, and this will be 2 and 53. And one thing I'm going to notice is, hey, 53 is prime. So I can't do anything more with this, so I can't actually simplify the square root of 106. So that's as simple as it gets. And there's my answer. Oops. So that's just one quick check you always want to do if you're looking for a simplest radical form. Okay, so in class, we're going to look at the Pythagorean theorem and see how we can use it to derive a distance formula, and then you can look at how to use the distance formula to just plug in your values and find distance. All right. If you have any questions, please come back to class and ask them.